All right, everybody, welcome to our lecture on strings and characters. I'll try to keep this lecture relatively short, and that the whole goal of this is to introduce strings, especially if you haven't used them before, and just kind of work through how we declare, how we define a string in our programs. You may or may not have talked about these in 150. It's usually pretty mixed bag by the time people get to 250, whether or not they talked about them if they had time. I'm just going to go on the assumption that you haven't, and if you have, then hopefully this is just a good review. With strings, what we're looking at, first thing we have to understand is what's called the character constant. And what a character constant is this just a single character enclosed in a single quote that represents a numeric value. These integer values or numeric values typically map to the machine's character set, and usually we're dealing with ASCII characters. So if you do a search on the internet or go to ASCIItable.com, you'll see, let me see if I can zoom in a little bit here. I've got the loudest clicking buttons on my touchpad, so apologize if that gets distracting. I won't be on this laptop for long. All right, so here's our ASCII table. If you've never seen this before, this is just how we map the characters, essentially the characters on our keyboard, and then there's some extended characters that we don't have. But for the most part, the characters on the keyboard, this is how we map them to integer or numeric values in the machine. So when we talk about the ASCII table, we talk about these character constants, then we're talking about finding this mapping between, let's go to here. So decimal, hexadecimal, octal, HTML, and the character. So we care about the red, because those are the characters that we're looking up, and we only care about the decimal representation. So if we wanted to find the numeric value for an uppercase A, we'd see that it has a value of 65. If we wanted to find the numeric value for a lowercase a, we'd see that it has a value of 97. Okay, so each character, upper and lower case, has a different numeric value. We also have in this middle column, or the second column in, we have ASCII characters for the space, for the exclamation point, for numeric values. The leftmost column, you have a lot of these are special. They're ones that you don't see. This very first one, this null value, this will be of particular importance to it. The rest of these, we really don't work with. We don't really have to worry about them. The tab is probably the easiest thing to look at. I mean, if you were working with file manipulation, it could be a tab-separated document, and you'd look for that character. And when you're looking at the character, you'd look for an integer value of 9. So at any point when we're dealing with strings, we're dealing with characters and character constants, if you don't know, you need to look up a specific value. In the lab for this, for strings, you're going to have to look up or find the space in a string that a user enters. So here you'd come in and you'd see that the space character is decimal 32. So you could compare that in your code, and then you'd know, we'll store that, that multi-word string in an array. You'll know what element in the array contains the space character. All right, so just make sure that maybe you take a few minutes, a couple minutes, and just look through this table and just somewhat familiarize yourself. We care about the characters in the red, and then its decimal value. All right, we'll go through a couple different ways in how we define strings. There is a specific or a special way using a string literal, and a string literal is just essentially anything in double quotes. Okay, so you see an example of that here. You'll see an example in the code, and I'll explain it a little bit better there. Big picture, though, I kind of jumped ahead a little bit, but big picture, what is a string? And a string in most programming languages, in fact, everyone I've used, it's usually a special value. It usually is enclosed in double quotes, and C it's a little bit different because we use character constants and character arrays, but it's typically enclosed in double quotes, and it's any combination of those ASCII characters, typically the printable ones. It's the ones that we see, so alphanumeric, spaces, dashes, so those a couple of those special characters, and it gets treated as one single value. So up until now in our programs, we've been assigning, for the most part, we've been using numeric values, and we assign a numeric value to a variable. Well, now we can do the same thing, except we'll assign it a string. So it's just an arbitrary length of arbitrary content, but it's typically alphanumeric with those special spaces and dashes and things. All right, when you get down to it then, a string in C, at least there's going to be two types of strings that we'll talk about. Those that we really can't manipulate, and then strings that we can manipulate. And oftentimes that you're going to want to do both in your program. So as far as the strings that we can manipulate, they're really just a character array, a char array that has a special ending, and that's that null character. Okay, so if we go back and take a look at the ASCII table, null character is a decimal value of 0. It's important that you know that because all strings, no matter what, all strings, no matter what type we're using, they have to be null terminated. Okay, so for the most part, they're just arrays of chars ending in the null termination character. Okay, that's the character constant. You can represent it using a backslash and a 0 if you surround it with these single quotes. You can also use its numeric value, so just 0. Okay, but it's absolutely critical that when we're working with strings that they're properly null terminated. If they're not properly null terminated, then unexpected things can happen in your program. And when you say that, when I say that, unexpected things can happen. It doesn't always happen, but the possibility exists that it can happen. And I'll show you an example here in the example code of where if we don't null terminate properly, the program doesn't behave as you would expect it to. So now that we kind of have an idea about strings, we can finally start putting stuff in our programs other than using things in our program other than just numeric values. All right, so we're not going to cover this slide because we're going to look at this in code. So we'll look at a few ways on how we can declare a string and then use them in our program. There's just one thing I want you to know, and then these are all the slides that we're going to look at today. There's about 4 more, and I'm going to provide more advanced string topics here in a second follow-on lecture. But that is that when you use string literals, okay, depending on how you use them, but typically when you use string literals, you'll use them with a pointer. And those are typically it's dependent on the implementation and the operating system and everything that it's running on, but typically they're put into read-only memory. Okay, so just general rule that if you want to manipulate a string, store it in a char array. If you don't need to manipulate it, then you can store it in a pointer. What I mean by manipulate is that you can iterate over every single character, check its value, change the value, transform it from uppercase to lowercase, remove it, whatever. Okay, and we'll get into that in the code. So let's take a look. As usual, I'll provide you with this version here, this code that we're looking at. And to try to facilitate this and reduce the typing and all the clicking that you hear in the microphone, I'm going to continue to comment out things and then uncomment them as we talk through them. So hopefully that doesn't get too confusing. To begin, okay, I'm going to just remove this define because I'm not actually using it. You'll see that there's a new include, and we're including the string header. I'm not actually using any of those functions right now, not in this code. I've made some modifications since the last time I used this file, so I'm going to go ahead and get rid of that as well. When we talk about more advanced string functions, like we can do 2 upper and 2 lower, and we can test if it's an alphanumeric character, and we can get the string length, then there's this whole library of functions that we'll want to use, and that's in the string.h file, this is the string header file. But for right now, for the introduction, we don't need any of that. So we'll go into main and we'll look at 2 variables, letter A and letter B. You can see they're both char type, and with letter A, I assign it a value, which is the character constant with A. Okay, character constants is anything enclosed as a single character enclosed with single quotes. Okay, so with A, that could be Z, that could be D, could be anything. But in this case, we'll keep it A. All right, the next one is letter B. And you can see that I assign it a numeric value. So keep in mind that a character constant represents an integer value that we could map to that ASCII table. So letter B is 66. If we go back to our ASCII table and we look up the decimal value of 66, we'll see that that's a capital B. Okay, so with that, make sure I save this file. And what we're going to do then is I'm going to print off. Okay, format specifier to print a character, char, %C, and %C, and then I'll print off the value of A, or the letter A, and I'll print off the value of the letter B variable. Okay, I'm still on my Windows machine, and so I'm still using Siglin. And so again, it's exactly the same. I'm still using GCC. You're still looking at the code that will compile on your platforms and in the IA lab. The only difference is that since it's on Windows, it's going to compile into a .exe format. And so when you see me run a.exe, that's the only difference. Okay, so just pretend that it's just a.out, normal as we've been doing. All right, so there we compiled it, and now we'll run it. And here's our output. Okay, the uppercase letter A, the uppercase letter B. All right, so you can use char variables to work with and manipulate character constants. Whether you use the character constant or you use a numeric value that represents that character constant, it doesn't matter. The two are interchangeable. I can assign integer values or I can assign that character constant. Okay, so let's move on to the next section here. Let's talk about defining a string. All right, here is our first string. So I'm just going to call all these variables that I'm declaring string 1, string 2, string 3, etc. You can see here that I said that strings are nothing but a char array. Okay, so we declared this string 1 as an array because we used opening and closing square brackets. The type of the array is char, and then I assign it using a string literal. Okay, so when we talked about string literals, this is a string literal. It's anything enclosed in double quotes inside of a C program. Okay, now I didn't define a size, and what's going to happen then when we compile and run is that the size of this array will automatically adjust to the value of the string literal. Each character represents an element in the array. Okay, so if we counted these characters, we'd have 12 elements plus a null termination character, so there'd be 13. Okay, so that's what happens if we declare an array, a char array, we don't define a size. It's the same exact thing that when we define arrays of other types. If I define an int array and I don't define the size, but I provide an initialization list, then the array will take the size based off of the number initializers in that list. All right, so the important thing with this is that not only we're not defining the size, the string 1 variable will automatically adjust, but it also will automatically null terminate. Okay, there are 3 or 4 ways that we're going to talk about defining strings, and there's one way we have to define the null termination ourselves, otherwise our program won't work correctly. All right, so here, and I left it in the comments, automatically null terminated. So let's move on to the next one. Okay, similar concept here. I declare string 2, so it's a char array called string 2. I don't define a size, but now I provided an initialization list. And this is very similar, it's identical in fact to how we do it with the numeric types, except that these are character constants instead of numeric values. We could, just like before with assigning the chars here, we could just use numeric values here. This is an array of type char, so as long as those integer values represent something in the ASCII table that you want, you're good to go. So character constants or an integer value, it doesn't matter. Important thing with this one is that once this program runs, again, it'll look at all the number of initializers, and that will be the size of the array, but we also have to null terminate. Okay, this is how we null terminate. If you want to use a character constant, you use 2 single quotes, and then it's the backslash and a 0. We also know that the null character is the value 0. So if we wanted to just do 0 there, we could do that as well. It doesn't matter to me. The only thing that matters is that your string is null terminated. All right, next way is to use a pointer. Okay, we're using a string literal and we're assigning it to a pointer. So we know how to define pointers. Pointers are defined using this asterisk character. This comes in between the type and the variable name. Okay, so just by looking at this part of the code, we know that we have a string pointer that's going to point to a char type. If we assign to that pointer then a string literal value, then string 3 now points to this string value. This string value gets put into memory, but it gets put somewhere read-only. Okay, so we cannot manipulate this. We cannot iterate over these values, these characters. We can't change them. We can't compare them. We can't do anything with them. Okay, so that is the big limitation with using a string pointer. The other thing with this one, again, automatically null terminated. Okay, so the only time you have to worry about null terminating your strings is when you do it with this initialization list. All right, so we have 3 strings. Then what we're going to do in this printf is we're going to print them off, use %s, and then we'll just do a dash dash, %s, dash dash, %s, and a new line. Okay, to print them off, we just have to do string 1, string 2, and string 3. So let's see how that looks. Well, that didn't look good. Okay, I didn't save it. try that again. All right, so there we go. Hello world, hello, and string pointer. Okay, so all those values printed off. What happens if I forget to null terminate? So we'll go ahead and we'll delete that. I'll save it this time and compile and run again. All right, so this is what happened. Notice anything weird? This middle value. So it should have just printed hello, but I forgot to null terminate, and now I got this weird result. And we'll at some point we'll go into the reason why that happens. Right now, you don't need to worry about it. All you need to know is or recognize that it wasn't null terminated and something unexpected happened. Okay, in this case, we printed off way more than we expected to be printed. HELLO, that's all that should have been printed, but we printed more. So we'll fix that. We'll add that null termination, and then we'll move on. So I'm going to comment out just the print part, and let's move on to the next thing I want to talk about. Okay, so one thing that you've probably noticed I haven't done is I haven't defined a string with a size. Okay, and you can do that like we have defined any other array types. And I'm going to combine declaring a string in that fashion along with using scanf. Okay, so there's kind of two ways that we're going to capture or use strings in the program. One is because you're going to hard code them, you're going to program them in. You know, hard coding is doing something like this. I declare a string and I assign it a value. I do this in my program. The other way is because we're going to capture it from the user. We're going to capture it from user input. And that's going to be what the string lab is over. There'll be two things we'll talk about. We're not going to talk about them in this lecture. We'll talk about them in the next. Scanf and then fgets. Okay, so we'll look at scanf here just as kind of a primer. One thing I want to point out, and this isn't just for scanf and fgets in particular, but kind of the course in general, 150, 250. We don't talk a lot of security. Okay, we focus really just on the programming. And so if you do any sort of research or reading online or other books, you'll probably see, hey, scanf and fgets are terrible, don't use them. And that, for the most part, is true. Okay, so at the end of the course, if we have time, if I haven't tried to cram too much or throw too much at you, I'll spend one lecture and we'll just talk about secure programming and C. But keep in mind that that's not the focus. I mean, null termination is important. It is important from a security standpoint, but it's also important because our programs just simply won't work without null terminating the strings, or there's the potential that they won't work correctly. So just keep that in mind as we're going through it. Security is not the focus at this point. Okay, so we can call this variable string4. It's a char array. It has a size 5. If we want to, once we declared a char array, we can use this initializer to initialize out all values, all elements of that array to 0. Okay, same concepts apply to other arrays and other variables. Once we declare it, we also want to initialize it. We want to 0 it out so that we prevent any future problems in our program. So I have string4. What's also important is that when you define the size, you need to account for the null termination character. Okay, so what I'm saying with this string declaration is that it's 5 elements. The last element is for null termination. The other 4 I can store characters in. Okay, so with a 5-element array, I can only store, one less than that size of actual characters. If it's 99, I can store 99 characters or 98 characters and save one element for the null termination. Okay, so when you define a string, when you define your char array, and you provide a size, you need to allow or save that last element for the null termination character. So when we do that, and then we try to capture some input from standard in using a scanf, then what we can do is we can use the format specifier to limit the amount of input coming in from standard in. So if it's a 5-element array, we need the last element for null termination. That means we can take 4 characters. So if we put a value in between the % and the s, then that means no matter how much the user types in, standard in will only read the first 4 characters. Okay, that ensures that we leave that 5th element for the null termination character. Once we do that, this is how we set up our scanf. So we set up the format specifier in a way that ensures that we limit the number of coming in and save 1 element for null termination, and then we just provide the string, the variable name the char array that we want to provide. Okay, we do not use the address operator with an array. Okay, because array is actually a pointer is pointing to a memory address, so we don't need to use that address operator with the array. And scanf will automatically null terminate. Okay, so this is another case where we don't have to worry about it. So let's see. Let's print this off. %s new line and string 4, and we'll just verify that this actually works the way that I expect it to, at least. Okay, so enter 4, go with test. Print it off test, everything works fine. If I run it again and I type test, 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 it only takes the first 4 characters. Test. Okay, so we're good to go. All right, this is important. Okay, make sure that you save the last element, no matter what size array, for the null termination character. All right, I'm going to comment out that print statement. Actually, I'm going to comment out this entire block because I don't want scanf to prompt me every time we run this program. Let's look at this next chunk of code right here. All right, as you can see in the comment, this will not work, and the reason why that is, well, again, we'll get into a little more details here down the road, but we call a variable string 5. It's char array. It has a size 20, and we initialize all values, all elements equal to 0, and that's good. That's what we're supposed to do. But now we want to assign a string. We want to assign a value to this string. Well, how do we do it? Well, one way is to iterate over the element, iterate over the array, and assign a value, a char constant, to each individual element. All right. The other way, we'll talk about some more advanced functions here in the next lecture. There'll be a string copy. That's the way we're going to want to do it. But you might be tempted to try this and just assign string 5 a string literal, and this does not work. Okay, string 5. This is an array. This is actually a pointer. It points to the memory address for the first element in the array, and since this is a pointer, we could assign it a memory address, but we can't assign it a string literal. Okay, so if this doesn't quite make sense to you yet, that's okay. The important thing is that you recognize that you cannot do this. Okay, that's all. The only reason I brought it up. And if you try to compile this now, you'll see here that you actually get an error, and it'll say here you can read through the error here, but bottom line is you can't assign to it. Okay, so incompatible types and assigning to type char array, okay, from char pointer. Okay, that is a pointer. Arrays really are pointers, and so that's exactly what that error means. You just can't do it. All right, so let's move on, and I want to start at least introducing how we walk through an array. So I'm using string 4, and I'm going to go back up into my program here, and tell you what, let's just pull this guy out. I just need a string to work with, so I'm going to move him down here, and we'll declare let's do that. All right, so oh, you know what? Just because I don't want to take the chance this is going to screw up any of my code because I'm too far into this recording. This is what I was using, so I'm just going to pull this down here. Okay, so we'll go back to this example. When this program runs, then what I'll do is I'll prompt myself to enter a string. It's going to be string 4. It's going to have five elements, but I'm only going to take the first 4. And then after I have a value into that string, then we'll take a look at iterating over that array. So let's get rid of one more thing. All right. So how does that look? Well, it's just a for loop. We're just iterating over an array. Okay, so while I've kind of been pushing this whole let's iterate over arrays and compute averages and compute sums and everything is because we're going to keep doing that, and we're going to kind of take it up a notch, I guess you could say, with strings. So standard loop, standard array iteration. There's really nothing special about it. Declare a counter. We initialize it equal to 0. This is an array. We want to start at the first element. I is less than 5. So from 0 to 4 is 5 iterations. That's the 5 elements. That's the size of our array. Increment by 1. And then in here, all I'm going to do is I'm going to print off both the character constant. So what's the character? What character are we representing? And what's its numeric value? Okay, and you can see that I can do that using the same value, using the same element. Okay, so it's interchangeable, whether I represent or display the character or the integer numeric value based on the ASCII table, it doesn't matter. They really are interchangeable. So let's go ahead and we'll now compile that. Okay, let's see, I made a mistake somewhere. String 4. Char string 4, did I forget to save? Oh, yeah, here we go. So what did I do? Okay, it says string 4 undeclared, and that's because I didn't comment this out completely. So I tried to use string 4 before it was declared in that part. So I'll just make sure that's commented out. Go to compile again. Okay, now we're back in business, and we'll run the program. Okay, nothing happened. So I still have something. Oh, and now my removing that comment commented out all of my code. So we'll try this one more time. And let's just put this right here. Okay, now we'll compile it. It should run. All right, so enter 4 characters. I'll enter in the word test. And what do we have? Okay, so let's go through this output. And I said that we're going to print off where I'm going to enter a value. We're going to store that value into an array, and then we're going to iterate over every single element of that array and print off that element. We're going to print it off as a character and its numeric value. Okay, so here's the output. You can see I entered in test. We have T-E-S-T. After each line, I included a new line, so that's why you're seeing this each on a different line of output. And then we have the numeric value. So sure enough, if we looked up those numeric values, you'd see that they were that they represent the characters that we're looking at. This last piece, what is this? Well, that string is null terminated. We just iterated over every single element of that string. That includes the null termination character. Okay, null termination is one of those special characters that's not representable by something we can see. We can see its numeric value, but there's no character for us to print. It doesn't print null, it doesn't print nil, it doesn't print anything. So that's what we have right here. Okay, we have the null termination character being printed, and the reason why I'm printing off the ASCII decimal values is so you can see there is the 0. So if we want to correct that, then we just have to make sure that when we're iterating over a string, we don't iterate over that null termination character. So in this case, we know that even though the string has a size of 5, we only want to iterate over the first 4 characters. So if I change my condition to say I is less than 4, from 0 to 3 is 4, will provide 4 iterations. Now we can recompile, run the code, type in the word test, and there we go. You can see that there is no null termination character. All right, and then these 4 dots, that's just something that I have right here. All right, the last thing I want to look at, and this is pretty straightforward. Okay, same exact thing, but now we can change a little bit on, we can start to change our logic, our conditions, to change the way our loops iterate. So instead of doing a size, instead of saying, I is less than 4, I is less than 5, or something along that lines, we haven't talked about a way to get the length of the string. We will talk about that in the next lecture. But right now, what we can do is we can say, well, as long as the value of the element is not equal to 0, then go ahead and continue to iterate. You don't have to worry about that conflicting with the actual numeric value 0. Okay, if we look at the ASCII table, the actual numeric value 0 has a decimal value of 48. Okay, so characters, the only character that has a decimal value of 0 is the null termination character. So we look at this, we set this condition. What you'll see here when we run the program, this will separate the output from this first loop and the second loop. And you'll see that now that works, and that we don't have to worry about the null termination character because it's handled in the condition of our loop itself. Okay, and there it is, right? We don't see a 0 because we didn't print out the null termination character. In Cygwin, you can see this line right here, this new line. If you're really paying attention, notice that. That's just a Cygwin thing. Okay, if you guys are running this on Linux, and I did, it's not there. So there's no extra new line here because of any output that we're generating or because anything weird in a program. That's just a Cygwin thing, so don't worry about that. So that's it. That's our intro to strings. Again, at this point, you should have, be able to declare one, print it off, and then start to at least try to iterate over. So, have any questions? I'll be posting one more lecture about strings, and that lecture will get into more details about character manipulation, character handling libraries, 2 upper, 2 lower, string length, string copy, some of the other things that we're going to need later on this semester. So let me know if you have any questions. Otherwise, thanks.